Hello everyone, good morning guys, and today the topic that we are going to discuss is scalar and vector quantities. Yes, there are a lot of questions which are asked in both SSCs and railways. What is scalar and what is vector quantity? So in order to understand that in the easiest way, I have used this animation, right? So let us see what it is all about. But yes, one thing I want to make it very clear that these questions are asked in examination, and yes, this is one of the topic which is common for both SSC and RRB. So let's start with the topic. So guys, I have an animation, but in order to understand this animation, I need to tell you few basics. What is it? So if I talk about a scalar and vector quantity, we must know about what is scalar and what is vector quantity. See, the topic is scalar and vectors. So first of all, let me write something for you. Guys, let's say I want to know what is the weight of this particular watch. So you'll say, sir, this watch, we guess, sir, it might be there in grams. So you'll tell, so if you're talking about the weight of this watch, or if I'll ask about the mass of this watch, that would be better. So if you tell about mass, so it would be approx 50 grams. Let's say this is the example. Now if I'm writing 50 grams, what does it mean basically? So this 50 actually represents the magnitude, and gram, that is basically the unit, right? So for the measurement, we need two parameters. One is the magnitude, another one is the unit. But guys, in this case, there is no direction involved, right? There is no such direction. Then where direction is involved? So let us say I'm talking about displacement. This was all about mass, right? If I talk about displacement, if I talk about weight, if I talk about force, their direction is also involved. So yes, the quantities in which magnitude plus direction, if these things are involved, we'll say, sir, it is a vector quantity. And do not worry about it, I'm going to explain this in the easiest way using the animation. So what we have understood till now, so if I talk about the scalar quantity, so it has just the magnitude, but vector quantity has both magnitude and direction. So this was the first point. The second point is, here in the scalar quantity, we have the numeric value and the unit. For example, we have already discussed it was 50 grams. And here in the vector quantity, we will have the numeric value, unit, and also the direction. For example, 50 kilometers in the east. So 50 kilometers in the east, that means we are talking about the magnitude also and direction as well, right? Okay. So in the scalar quantity, so we go with the simple algebraic addition. That is the addition that we used to go in the mathematics. So let's talk about, let's say I'm asking you what is 5 plus 10. So you directly say, sir, that's 15, right? But what if I ask you about the vector addition rule? What is it? So my question is 5i plus 5 of minus I. It is going to give you what? So 5i plus 5 of minus I is going to give you 0. So here, this is actually the vector addition. I know, still there might be some confusion, but do not worry. Within 2 minutes, we'll be understanding it by animation. It will be very easy. Okay, so the examples of scalar quantities are speed, mass, time, and volume. Talking about the vector quantity, so it's velocity, force, acceleration, drag. So these are the examples of vector quantity. So yes, vector quantity is in action. So we can talk about force. What is it? So the push or pull acting upon an object in a specific targeted direction. So that is force. And yes, force and weight, that is one and the same thing. This is the question from RRB JE as well. That what is the unit of weight? So the unit of weight is basically Newton. And yes, the unit of force is also Newton. They are one and the same thing. Similarly, velocity. What is it? So if I talk about velocity, so yes, this is a scalar quantity where displacement is involved, and acceleration, the rate of change of velocity. So these are actually the vector quantities. And talking about the scalar, so as discussed, so if you talk about the scalar quantity, here only numerical magnitude and the units are used. So here no direction is involved. But if I talk about vector notation, vectors are distinguished by an arrow placed above the variable like this. We're talking about this arrow, and it is 30 meter per second in the east. So this is basically the magnitude and this is the direction. So this was all about the theoretical portion. It's the time to understand animation now. So let's start with the animation again. See, In order to understand this, I'll start the whole animation again. Yeah. So guys, there's a question for you. There are two bulbs here, and the current is flowing, because of which the bulb is glowing. So can you please tell me, is it a vector quantity or is it a scalar quantity? So you'll say, sir, see, when you're talking about the current, we are aware of what is current. So for the current, what is it? So that is the flow of charge. What is it? The flow of charge. Why I'm telling this? This is again from previous year question. So you must remember this. Guys, charges may be positive, they may be negative. If there is flow of positive charge in x direction, current is also going to flow in the same direction. Charges and current, please remember, the same direction in which the positive charge was moving, current is going to flow in the same direction. But what about negative charge? If negative charge is flowing in x direction, so the current is going to flow in the opposite direction. So this gives us clarity. So if you're talking about the current, so obviously there is the flow of charge, and yes, that means, sir, direction is involved, right? So let us see what will be your answer. Will it be scalar or will it be vector? So Chalchitra, hello Deepen. So here guys, if you think this is a vector quantity because of this direction, so guys, you are wrong. Now why you are wrong, this we are going to understand in the next 10 minutes. So let's start with this topic now again. Yeah. So current is actually the vector, sorry, the scalar quantity. It's not a vector. Now why is it so? This is going to give you the clarity now. So let's start. See guys, scalar or vector, that's the question I've already asked. So proceeding further. So let us say there's a robot that is standing on this part. Fine. Now my question is, if I'll tell robot that you have to come 5 kilometers, so will it be able to move here? No, because let us say after selection I'm calling you people for the party. I'm throwing a party and I'm saying, Deepen, can you please come to my office? Now Deepen is actually on a location which has 4 different directions: east, west, north, south. And at this location, if I tell Deepen, you are just 5 kilometers away from my office, you just come straight. Now this straight means what? This, this or this. So here my magnitude alone is not going to work out. So what I have to tell? I have to tell that Deepen, you need to travel 5 kilometers in the east or in the west or in the north or in the south, which means if I am going to give the command to this particular robot, it will surely have the doubt, so you have to tell me the direction as well, right? So here it had 4 directions: east, west, north and south. So obviously it cannot move until and unless I give him the specific direction. So he's asking, where should I go, right? So that means only and only magnitude is not applicable here, right? So yes, when we were asking about traveling for 5 kilometers, only it was including the magnitude, and here direction distance can be involved, and distance is actually the scalar quantity. But what about vector quantity? So vector quantities are the one in which direction is also involved. So here we'll take the example of displacement. For better example, let us say this is the example here. So one by one, let it come. So see, 5 kilometer, if I want to say that you have to come here, so I'll give the command 5 kilometer north, direction is involved. Similarly, if I want to ask it to come 5 kilometers in the south, it will be able to move 5 kilometers in the south. Similarly, if we need to move in the east, so I need to give the command 5 kilometer east, so it will be able to move 5 kilometers in the east direction, and the same condition is for the west as well, right? So this gives us clarity that magnitude and direction, when they are involved, so this is the perfect example of vector quantity. Fine. So now talking about that vector addition. So what is it? So that vector addition, algebraic sum, right? So let's understand about that also. So this is the example of displacement where we can say it is a vector quantity as both the things are involved. Now one more thing, guys, that's not in our syllabus, but you need to understand it. Guys, during our 11th and 12th standard, we have studied this, right? What is it? If I'll draw a graph, so this was x-axis, this was y-axis, this was minus x, and this was minus y. Now, if I want to know the direction, what I'll do, I'll just change the color. For moving towards the x, I'll use I cap. For moving towards minus x, I'll use minus I cap. For moving towards y, I'll use j cap. And while moving towards minus y, I'll use minus j cap, right? So here, one more thing is there. So this is only and only about the two dimensions, that is x and y. What if I ask about the z direction then? So for the z direction, obviously I cannot draw it, but I'll directly write it. So it will be k cap. So k cap actually tells us that it is in the z direction. And what if we are talking about the direction which is in the backward direction of this board? That will be minus z. So obviously that's not in the syllabus. You must understand, for the x-axis I am going with I cap, for minus x minus I cap, for y plus j cap, and for minus y minus j cap. Guys, please give me the confirmation. Is each and everything clear here? If that is clear, I am proceeding with the animation. Yes, guys. So Chalchitra, Deepmani, and all the other candidates. Is it okay? Achha, voice is quite low. Let me increase the sound. And still, guys, if you have any doubt or queries, you can ask me here. I have increased the voice. Please check. Okay, fine. So proceeding further, guys, now I am giving a commands to the robot, and the commands are mentioned here. So I have asked robot to please move 10 km in the north. So obviously, because of this command, it can move 10 kilometers in the north. The second command is you have to move 3 km in the south. So please watch this carefully. It is going to clear your all the concepts. Okay. Now moving 3 kilometers in the north, south, 1 kilometer in the north now, 1 kilometer up, then 8 kilometers in the south, so 8 kilometers downwards, then 2 kilometers in the east, so 2 kilometers here, and then 3 kilometers in the west, so minus 3 I cap. Cool. So guys, before proceeding, the commands which I was giving, I also involved the direction. So it is like 10 kilometers to the north, so that is 10j, 3 kilometers south, so that is minus 3j, 2 kilometers in the east, that is plus 2i, and 3 kilometers in the west, that is minus 3i. So this gives us clarity how these I cap, minus I cap, j cap, and minus j cap were used, right? Perfect. Now, if someone asks me, sir, what is the present position of this particular robot? So you will say, so the starting point was this, the origin was this, and if I'll remove all those conditions, because in displacement only the thing that is matter is the only thing that matters is your initial position and the final position. So initial position was this origin and the final position is this. So it doesn't matter what path has been taken. No, distance, in the distance we need to measure the complete path, but in the displacement it's just about the minimum distance or the shortest distance between the initial point and the final point. So initial point and final point, what is it? It's just 1 kilometer, that too in the west. So what I can write? Minus I cap. So yes, 1 kilometer west of the origin, and this is what displacement is, because in the displacement we were using the direction and the magnitude both. Okay. So for better understanding, I have a question. Guys, can you please tell me how much distance has been covered? So anyone, you have everything in front of a board. So what is the total distance covered here? So if we'll talk about the total distance, what you'll do? You'll just ignore the directions, right? And you will add these components. It is 10 plus 3 plus 1 plus 8 plus 2 plus 3. So this will give you the distance actually, right? So for the displacement, we were using the direction also. So yes, by calculating it, our final value was minus 1, and minus I cap was representing, see, minus I means 1 kilometer, that too in the west direction. Okay, but what about distance? So for the distance, you need to add all these components one by one. So first 10, then 3, no direction, then 1, then 8, can you see, and then 2, then 3, and yes, now after adding all of them you will get the distance of 27 kilometers here. So for the distance and for the displacement, it gives us clarity that for the distance we were only and only using the magnitude. So distance, speed, density, mass, they all are the examples of scalar quantities. What if we are talking about the vector? So vector will involve both magnitude and also the direction. So for example, displacement is the perfect example. So displacement, velocity, force. So these are the examples of vector quantities. If you have any doubts or queries, you can ask me here because I want to explain something now. So guys, again, my question is same. What is a current? Is it a scalar quantity? Is it a vector quantity? So in order to understand it now, both the concepts are clear. What is scalar? What is vector? So what we can say? We'll say, sir, see, what is current? So that is actually the flow of charge, right? So if I'm talking about the electric current, it is the flow of charge. Now here, electron flow is there and electrons are flowing in this direction. So current will flow in the opposite direction, right? So current will flow in this direction. 1 second. So since current flow is here, the direction of the current is this. It gives us clarity, sir, that here direction is also involved, right? Okay. So I have already discussed about it. So let's say it's 10 ampere and here on magnitude and also we were talking about the direction, right? So magnitude plus direction, both the things are there. So it must be scalar, it must be vector, it must be vector, right? But it's not the vector. Why? I have to explain one more thing here. So I'll just take my board back again. 1 second, guys. And here on the first slide where I was explaining you the concept, I'll just remove this part. 1 second. Yes. Okay. Now please focus on this point. If I'm talking about the scalar quantity has only magnitude, right? No direction. But talking about the vector quantities, so it has both magnitude and also the direction. Okay. But these things are not enough. Here you need to add one more thing which Chalchitra has told us. And what is that, Chalchitra? The point is that it just follows algebraic sum. And this follows vector law of addition. It may be the parallelogram law, it may be the triangular law, whatsoever it is. So yes, now check out the third condition in the animation. If I'll talk about the third condition in the animation, just have a look. Guys, here the perfect example can be taken with the help of force. Here, so let's say there's a mass or there's a weight of 10 kilogram which is kept, fine. Now what I'm doing, I'm just trying to push it with 10 newtons of the force from this direction, and also 10 newtons of force was given from this direction. Guys, how much force is being exerted on this particular object? What do you think? What should be the answer? So 10 Newton force is applied here. 10 Newton force is applied here. So according to you, do you seriously think that it is going to be 20 Newton force that is acting on the object? No, sir. I have an example. This is my water bottle. See, if I talk about this water bottle, I have this my water bottle. Now guys, if I'll not exert any force from this direction, so obviously 10 Newton force will shift it towards this side. And if I'm not applying force from this side, so this 10 Newton force will be applied on the water and it will move in this side. But if I'm applying 10 Newton force from both the directions, so neither the bottle will go in the left direction nor bottle is going to go in the right direction, which means the net force on this particular water bottle is 0. 0. So 10 plus 10 is 20. How you can say that it is 0? It will be 0 because Sachi, Deepan, Chalchitra, you all must remember. So here direction is actually involved. So it's not 10 plus 10 that is going to give 20. No, that's wrong basically. What is going to happen? So since 10 Newton force is applied in the east direction, so what I can write? That is basically 10 I cap, and this is actually in the minus x direction, that is minus I cap. So it will be 10 I cap plus of 10 minus I cap, that means 10 I cap minus 10 I cap. So see, plus 10 I cap minus 10 I cap, that means it is giving you 0 value, right? And but in the current case, in the case of current, so 10 ampere current was coming from this direction and 10 ampere current was coming from this direction. Guys, at this particular point, that is if I'll talk about the net current, what will be the value of current? So here it's not like force, that is 10 I cap minus 10 I cap 0. No. So it is actually 10 ampere and 10 ampere, and its total value will be 20 amperes here. And this is what algebraic sum is. So it is not following the vector law of addition. One second, see. So the net current will be what? So 10 plus 10. So here vector addition is not followed, no, because directions are not involved here. Here the total sum will be 10 plus 10, which is total going to give you 20 ampere value. Understood? So now we have understood why this current was scalar and how this particular force was actually the vector quantity. So this gives us clarity about the scalar and vector quantities, and in the examination or in the daily life also you can easily link using this particular animation. Tell me guys, is each and everything clear here? If you have any doubts, any queries, you can just let me know. So guys, for the concepts, like we have already discussed the 5 kingdom classifications, we have already discussed the scalar and vector quantities, and also we have discussed the blood transfusion. So on the daily basis at 8 AM, I'll be bringing those concepts which are repeatedly asked in the examinations and along with the animation. So I want that in the comment section, how was the class, and in the tomorrow session, which particular topic do you want to study? So if you feel like this topic is very difficult, if this topic is so can you explain it in the easiest way? So guys, I have all those topics, whether you're talking about the environment, if you talk about the computer, if you talk about the science, you'll talk about the history, I have everything, and I have already created all those content. And yes, I have the animations for most of the topics. So if you want to study human circulatory system, let me know. If you want to study about biotech part, you can just let me know. For the ecosystem, everything is there. Okay, so thank you guys for being such a wonderful audience. So you can join me daily at 8 AM in the morning. And if you want to take any of the paid batches, what you can do? You can just go to the website. Here you will type Oliveboard, and on the first link you will just click on it, and you will find on the dashboard Railways and SSC Super Elite batch, which includes both Hindi and English medium courses. Here you will have tests, notes, live courses, everything is present. So you have to just click on it, and here all the SSC batches, all the railway batches, then we have mock test, typing test, everything is included. What you have to do, just click on this enroll now option. You can use the code select for the maximum discount, and it is of 59%. So yeah, just click on it, apply the coupon code select, and yes, you can avail the maximum discount here. So that's all from my end. We'll meet tomorrow now at sharp 8 AM. But I want this in the comment section, which topic you want to study. So all the very best for the examination. We'll meet tomorrow now. Bye bye guys. Take care. Jai Hind. Thank you Jalchit. Thank you Deepan. Thank you Sachi. Thank you everyone.